Hi guys, we are Team IOT VAIDYA and we are competing in Intel Ultimate Coder Challenge for IoT. We are team number 3 and we are building cognitive healthcare solution for rural areas. In this video we will show you the demonstration of a project, but first let me take you to the basic overview of a project. So the patient will be connected to the Arduino 101 and Intel Edison boards using the sensors GSR, BP, ECG and temperature. The entire data will be sent to the Dell gateway using the BLE and Wi-Fi or all join, and on the Dell gateway we'll be processing the data for anomaly detection using the open source Newpic project, and from gateway to the cloud we'll be sending using MQTT or HTTP protocol, and also we'll be sending the anomaly score. And on the cloud side we are using IBM Bluemix, which will be interfaced with the MongoDB for data storage, and we'll be sending the feedback as a SMS to the patient. Before going to the demonstration part, I'll walk you through the sensors quickly. So we have ECG electrodes which are connected with the areas.Not ADC, which in turn is connected with the Intel Edison board, and the Edison board is connected with the RGB Groove LCD, and the connection between the electrodes and ADS1298 is serial. It is connected using DB15 connector, and the connection between the ADS1298 and the Edison board is using the SPI. And here we have blood pressure sensor, which will be used to send the systolic diastolic blood pressure, and also it will be measuring the heart rate. And the galvanic skin response will be sensed by this GSR sensor, and this is a Groove Shield plus Arduino 101 board, and this is the digital temperature sensor DS18B20. After going through the sensors, let me take you to the doctor's web page. So on the doctor's end, I log in using my account, and these are the patients which have been registered, and you can view the reports. We'll do that later. So currently there are 0 new patients. Now I'll log it out, and now we'll start with the data acquisition part. As you can see, all the sensors have been placed on the patient's body, and now we'll start with the data acquisition part. So this is the gateway side. We have connected a camera also for taking the picture of a patient, or if he has any symptoms to show, he can click a photo. And this is the LED monitor for viewing purpose, and let us begin with the acquisition. So this opens a form which is to be filled, the all details like name, age, contact number, and the location. So now the details have been filled, and now let's start with each module. So first the GSR. As you can see, GSR is done. Now let's start with the blood pressure. So for that we will first start the BP module. And we'll press BP button. So BP and heart rate are also done. It's time for ECG. ECG and temperature have been recorded now. The time is for taking profile picture. So for that we'll have to press this submit button, and profile has been clicked. Now it's time for the symptoms. and the data is published using the MQTT, and the report has been published by HTTP as well. So now everything is done from the gateway side. We'll see on the doctor's end. Before showing you the doctor's end, let me quickly show you how we are detecting anomaly. So like we have acquired the ECG data here in the ECG.csv file. So this folder contains the Newpic files which will be responsible for anomaly detection. So we have already swarmed over the data sets and came up with the model params, which consist of the best model parameters, and we'll run this script for anomaly detection. So it will feed in this ECG.csv as the input, and will populate the screen with the anomaly. So here the screen is divided into two parts. The above part will show you the ECG data stream. The blue lines show the actual ECG and the green one is the predicted. It takes some time for learning, so we'll have to wait for the anomaly detection to take place. So, and the below segment will show you the anomalies if present. So we expect that there will be anomaly because the ECG data is not very fine. We have written a blog on Newpic. You can find the link given below. Newpic is an open source project by Numenta, and there you see there is one anomaly there. So what Newpic is doing is it is showing the anomalies on the screen, and also it is pushing the data to a file called ECG_out.csv. So it will be present in this drive. Where is it? Yeah, there it is. So it will contain the anomaly scores. So the fourth column is anomaly score, and this data will be processed to find if the prediction is correct or not, and for further processing. So the Newpic has read 700 lines up till now. So 2 anomalies have been detected. Similarly, all the anomalies will just pop up, and the Newpic will catch if it happens. Now, having done this, we'll go to the doctor's end and see what happens on the web page. Now that the patient reports have been sent to doctor, let's see what happens at the doctor's end. So what you're seeing here is a web application that is hosted on IBM Bluemix. The URL is iot-vaidya.myBluemix.net. So I've created one account in this, and similarly the doctors will be required to make an account. I'll log in and I'll see the list of patients. So we can see Manoj is listed here. Also we have this notification which says that there is one new patient, and let's see the report. What you're seeing here is the entire report. On the left side we have basic information of Manoj, age, contact and location. On the right side this is the photo segment which will contain the symptoms, and here we have the GSR segment. The graph of galvanic response is plotted so doctor can review it. Also we have the ECG plot, so you can see the ECG is not very accurate, and that is the reason the analysis says that arrhythmia is probable. There is probably some chance of arrhythmia. Also at the bottom you can see the temperature 37 degrees, pulse 78 bpm. Also the systolic pressure is 100 and diastolic is 81. So one more thing, suppose doctor wants to send a prescription or warning, he can write it here. He can write in any preferred language, so I'll prefer English, and it will be translated to the regional language of the patient. So we'll write, say, Manoj you, and I'll send it. So once sent, it will call a service which will translate this entire text. So the API name is mymemory.translated.net. So I'll press send and it will redirect to the login page, and we'll get a message on the mobile. Yeah, we got it. So you can see this message says that मनोज आप अतालता से पीड़ित हैं. So in English it means Manoj, you may be suffering from arrhythmia. So that's it. At last, we'd like to thank Intel for giving us this grand opportunity to make cognitive healthcare solution. Those 8 weeks were really wonderful and we learned a lot. Thank you once again.